All right, now it's really weird. We think of things as having different weights. And I think subconsciously, all of us know that heavier objects are pulled to the ground with a stronger force. And we throw things and drop things all the time. But the first time that you actually do this, one pair of objects next to another, it's kind of astounding that a really heavy object like that, even if I grab a bowling ball or even anything, a car, I could put a car in a crane and drop it, and neglecting air resistance, they will hit the ground at the same time. Why is that the case? If the heavy object is pulled down harder, why doesn't it accelerate down more and hit the ground first? We're going to answer that today. But before we do that, I want to turn our attention to what happens when we shoot a projectile out at a velocity. Does gravity act the same, or does gravity act on moving objects differently? So here we have this little toy gun here, and we have these little styrofoam bullets which can go inside of it. And what I've done is I've taken one of them and I've put this paper clip through so that I can kind of hook it on there. And so the reason I'm doing that is so that I can put it in the gun and I can suspend another one of these darts down below like this. And so what's going to happen is as I shoot a dart out, then what's going to happen is this dart is going to shoot out, and then this one is going to drop as soon as this one leaves the barrel. And so we're going to get a direct comparison to a curved trajectory flying very fast one direction compared to the same mass bullet, I mean they're pretty close to the same, falling down, straight down. So one moving horizontally, but of course it's going to start to curve down, and then another one going straight down. What do you think is going to happen? Based on what we've seen today, do you think they're going to hit the ground at the same time or not? Let's find out. Here we shoot the bullets over different distances of length, starting with shorter distances and moving our way to farther distances. And we find out that every single time both bullets hit the ground at exactly the same time. I don't know about you, but every single time I look at this, it's still amazing that it actually happens this way. It works this way because no matter how much horizontal velocity you have, gravity is always acting in the down direction, and it's pulling you down at the same acceleration no matter how fast horizontally you're moving. We say that gravity is a vector, which means it has a magnitude or a strength and also a direction associated with it. I wanted to verify this effect at longer ranges outside. You can see it was really difficult to hold the bow exactly level, and of course the wind and air resistance played an effect, but in general both bullets hit the ground pretty close to the same time. All right, now I'm going to give you the executive summary as to why this happens. It's really, really incredible. Not only do any two objects with differing masses hit the ground at the same time, even though one is being pulled down harder, but if you take one of the objects, either one, and throw it horizontally, it will still hit the ground at the same time as an object dropped from a stationary point of view, no matter how fast horizontally it has traveled. Theoretically, even firing a bullet and dropping a bullet, they will theoretically hit the ground at the same time, although air resistance obviously changes the result. On the moon, they absolutely would hit the ground at the same time.